So, I want you to just take a second and like imagine looking up at the night sky.
Right.
You see the stars, the faint glow of the planets, and really think about what you're actually looking at. Like, are those planets just randomly scattered rocks?
Just kind of floating up there.
Exactly.
Yeah.
Did they simply settle wherever gravity happened to leave them after, billions of years of chaotic, violent smashing and crashing? Or, and this is the big question, is there a hidden, precise mathematical ladder organizing our entire cosmic neighborhood?
Which is, honestly, the ultimate question of celestial mechanics. I mean, we are so conditioned to think of the early solar system as this violently chaotic demolition derby of protoplanets and asteroids.
Yeah, just rocks crashing into each other.
Right, totally random. So proposing that a perfect mathematical order sits underneath all that chaos, it feels deeply counterintuitive. It challenges our basic assumption that the universe is just, a messy series of accidents.
Which is why today's deep dive is just so mind-bending. We are looking at a really fascinating scientific preprint from 2026 by an independent researcher named Salah Eddin-Gurbi.
Yes, harmonic architecture of the solar system.
That's the one. And our mission today is to explore this astonishingly accurate new mathematical framework, because this model suggests that our planetary orbits are actually locked into a quantized sequence, and it's based on a specific mathematical constant called the silver ratio. So we're going to explore how this math works and see if this model can actually predict hidden structures in our solar system that we haven't even discovered yet.
And I think the ambition of this paper is really what stands out immediately. It isn't merely, looking backward to force a fit onto the data we already have.
Right.
It is making bold, falsifiable predictions about what we should find if we look closer at specific regions of space. But to really grasp this hidden architecture, we kind of have to start with the mathematical key the author uses to unlock the whole thing.
The silver ratio.
Exactly, the silver ratio.
Now, most of us have heard of the golden ratio, right? That famous sequence you see in, like, the spiral of a seashell or the shape of a hurricane.
Members of a galaxy.
Yeah, exactly. So what separates the golden ratio from the silver ratio?
Well, while the golden ratio gets all the mainstream attention, the silver ratio is actually equally fundamental in mathematics. Algebraically, the silver ratio is just 1 plus the square root of 2.
Okay, 1 plus the square root of 2.
Right. And that single irrational number is really the engine driving this entire model, which the paper calls the silver ratio harmonic framework, or SRHF.
SRHF, got it.
But the elegance of this theory really emerges when you look at where that number comes from geometrically. The author doesn't just, pull the square root of 2 out of thin air. He derives all the orbital constants from a very classical geometric construction called a Celtic cross.
Okay, let's try to visualize this for everyone listening. The paper includes this diagram of a 3x3 grid. So picture a perfect tic-tac-toe board where every square is exactly the same size.
Right, a standard unit square grid.
Yeah.
Now, from the very center of that tic-tac-toe board, you start drawing concentric circles that expand outward.
Like a ripple in a pond.
Like a ripple, yeah.
Yeah.
And you also draw specific circles anchored at the 4 corners of the grid. When you do this, those expanding circles intersect the straight lines of the squares at very specific points.
Okay, I'm picturing it.
And because the diagonal of any square is intrinsically linked to the square root of 2, the ratios of the distances between these intersection points are completely dictated by the silver ratio.
So you start with a totally flat, two-dimensional drawing, just circles and squares overlapping, and that geometry just spits out a set of rigid proportions.
Proportions that the author then applies to three-dimensional physical space. That's the core hypothesis of the SRHF. It argues that in a gravitationally bound system like our solar system, the stable orbital radii,
meaning the actual distances where planets can survive over billions of years without crashing?
exactly, those stable distances can be parameterized by rational functions of this silver ratio. So the orbits form this rigid, quantized sequence stretching all the way from Mercury out to Pluto.
Okay, let me try to unpack this with an analogy. If you've ever plucked a guitar string, you know it doesn't just produce a chaotic mush of sound.
Right.
It produces a specific note because of where the frets are placed along the neck of the instrument. The string can only really vibrate in specific harmonic fractions.
Yes, perfectly said.
So what this paper is suggesting is that the gravity of the sun is that string, and the solar system has frets. The planets are sitting on specific, quantized mathematical frets dictated by this silver ratio geometry.
That analogy perfectly captures the mechanics of a quantized system. A planet cannot just exist anywhere. If it sits between the frets, the gravitational resonance of the system will eventually destabilize it.
Like it'll just throw it into the sun.
Throw it into the sun or eject it completely into deep space, yeah. The geometry of the silver ratio dictates where the frets must go to create a stable harmony.
Wow. It really gives you a whole new lens to view the solar system. It's an instrument tuned to a specific geometry. But to play devil's advocate here for a second.
Please do.
Humans have been looking for mathematical patterns in the stars since, like, the dawn of astronomy. The ancients were completely obsessed with the idea of a clockwork universe.
Oh, absolutely.
So why should we pay attention to this specific 2026 paper compared to what astronomers have tried and honestly failed to prove in the past?
Contextualizing this against historical models is so crucial because it highlights just how incredibly difficult this problem actually is. Let's look at Johannes Kepler, for instance.
Sure.
In 1619, Kepler was just desperate to find the hidden architecture of the solar system. He created this model using the Platonic solids, these perfect 3D geometric shapes like the cube, the tetrahedron, the dodecahedron.
Right.
And he nested them inside one another, alternating with spheres, because he believed the distances between the spheres dictated the planetary orbits.
Which is a beautiful, deeply poetic idea. I mean, he was basically looking for the literal geometry of the heavens.
It was an aesthetic masterpiece, definitely. But it was a mathematical failure. When we evaluate Kepler's Platonic model using modern, highly precise astronomical data, the average error in predicting the planetary distances is over 10.3%.
Yikes. 10%. I mean, in orbital mechanics, being off by 10% is pretty much catastrophic, right?
Oh, it's massive.
Yeah.
A 10% shift in Earth's orbit is the difference between a thriving biosphere and a completely frozen wasteland.
Okay, so Kepler's out.
Right. Then if we jump forward to 1772, we encounter the Titius-Bode law. This was an empirical mathematical sequence. You start with a sequence of numbers, you double them, add 4, and divide by 10.
Okay.
And amazingly, this simple arithmetic sequence seemed to perfectly predict the distances of the planets that were known at the time. When William Herschel discovered Uranus in 1781, it landed almost exactly where the Titius-Bode law predicted.
So it seemed like a total triumph at first.
It did. People thought they had solved it.
But it had a fatal flaw waiting in the dark.
Exactly. The discovery of Neptune just totally broke the model. The Titius-Bode law fails completely at the outer edges of the solar system. The prediction for Neptune is wildly off. So it was a mathematical illusion that really only worked for the inner neighborhood.
And this is where the silver ratio harmonic framework separates itself from that history.
Yes, because when you map the planetary distances from Mercury all the way to Pluto using this new silver ratio math, it maintains a mean absolute percentage error of just 0.72%.
Less than a 1% error across the entire solar system. That's wild.
It is. And if we look at the root mean square error, which measures the absolute physical deviation from the actual orbits, it is just 0.11 astronomical units.
And an astronomical unit is the distance from the Earth to the sun.
Correct. So on average, this model is off by barely a tenth of the distance between us and the sun. It completely crushes Kepler, and it is an order of magnitude more accurate than the Titius-Bode law without breaking down at the outer planets.
Okay, I do have to push back here, though.
Go for it.
Humans are pattern-seeking machines. Like, if I shoot a shotgun at the side of a barn and then go paint a bullseye around the tightest cluster of bullet holes, I look like a master marksman.
The Texas sharpshooter fallacy.
Exactly, the Texas sharpshooter fallacy. So if you give a mathematician a whiteboard and enough time, isn't it possible they just, tweaked a fraction here, added a square root there, and forced the math to fit the data? What are the odds this is just a really lucky cosmic coincidence?
And any rigorous scientific review would raise that exact objection. We absolutely have to rule out mathematical pareidolia, seeing faces in the clouds.
Right.
But the author anticipated this critique and actually calculated a statistical upper bound to answer it. The math is incredibly rigid. It doesn't allow for arbitrary tweaking. So if you treat each of the planetary matches as an independent statistical event...
So treating it like a cosmic roulette wheel, what are the odds the ball lands on the exact right number 9 times in a row?
Exactly. The probability of matching all these orbits by pure chance, keeping the error under a 2% range across the board, is roughly 10 to the power of negative 13.
10 to the negative 13, that's what? 0.000, 13 zeros, and then a 1.
Yes. That statistical bound effectively eliminates the Texas sharpshooter critique. The likelihood that a rigid geometric derivation from a Celtic cross just happens to accidentally map onto the physical reality of 9 separate orbital tracks with a 0.72% error is microscopic.
Wow, that really makes the historical comparison look even more impressive.
It really does.
But a truly robust scientific theory cannot just explain the past, right? Like, it's easy to predict yesterday's weather. A strong framework has to predict the unknown. And here's where the paper moves from interesting math into empirical physics, because this model predicts a ghost.
Yeah, this is where it gets really fun. Following the rungs of this silver ratio ladder outward from the sun, the math points to a glaring omission. There is a preferred harmonic node, a distinct rung on the ladder, where the math dictates a major planetary mass should be but isn't.
And the equation places this missing node at exactly 2.14 astronomical units from the sun,
Right.
which puts it right between Mars, which is sitting at 1.52 AU, and Jupiter, sitting way out at 5.20 AU. That 2.1 ORD AU spot is right inside the inner main asteroid belt.
Exactly. The author names this missing rung the Harmonia node. And the location is incredibly significant because it doesn't just sit randomly in the void. It acts as a natural mathematical boundary, like a fulcrum dividing the dense, rocky inner planets from the massive gas and ice giants of the outer solar system.
It's almost like walking through a beautifully planned neighborhood. You see houses spaced perfectly apart, following this clear architectural rhythm. But then right between two houses, you find an empty lot overgrown with weeds. But when you walk into that empty lot and brush away the dirt, you find a perfectly poured concrete foundation, complete with plumbing hookups. Even if the house itself is missing, the underlying architecture of the neighborhood demands that a house should be there.
That's a great way to think about it. The math proves the foundation is there. The paper maps out what is termed a harmonic basin around this 2.14 AU empty lot. And to prove how vital this spot is, the author runs an optimization test.
Okay, what does that mean?
Well, if you artificially slide the position of this theoretical Harmonia node closer to Mars or further toward Jupiter, the mathematical error for the entire solar system starts to dramatically climb. The tuning basically falls apart.
Interesting.
But at an optimally tuned 2.1437 AU, something magical happens. The algebraic prediction, the math, based purely on the square root of 2, perfectly converges with a completely different transcendental math prediction based on pi squared over 3.
Whoa, wait, back up. Pi squared over 3, where does pi come from?
Yeah.
You've only been talking about the square root of 2.
Right. This is where the geometric theory intersects with the physical reality of orbits. The silver ratio math is algebraic. It deals with linear proportions and roots.
Right.
But orbits are physical, quasi-circular paths governed by spherical geometry. That is the realm of transcendental numbers like pi. So what the author discovered is that at this specific point, 2.1437 AU, the rigid algebraic ladder of the silver ratio perfectly aligns with a geometric calculation involving the area and circumference of physical orbits.
So the two entirely different types of math basically shake hands at that exact coordinate.
They converged within 0.07%. It proves that this specific location is an incredibly deep, stable mathematical basin. And there is a fascinating systemic effect that proves Harmonia is structurally privileged. When the model optimizes for that exact empty lot, the residual error for Neptune's orbit billions of miles away at the edge of the solar system actually crosses zero.
Wait, really? Neptune's error goes to zero just by placing a ghost mass in the asteroid belt.
Yes, it causes a sign inversion in the outer system errors. Think of the solar system as a massive mobile hanging from a ceiling. If you place a weight at the Harmonia node, the entire mobile suddenly balances perfectly.
Wow.
The mathematical scale of the system reaches equilibrium. Harmonia is the structural fulcrum holding the inner and outer system together.
See, this specific prediction is why I was so eager to dive into this paper. It makes the model undeniably falsifiable in your lifetime. This isn't, string theory where we need a particle accelerator the size of the galaxy to prove it.
Exactly.
If future high-precision astronomical surveys like the ongoing Gaia DR3 mission scan the asteroid belt and find a clustering of mass, a density enhancement, or specific gravitational resonance right near 2.14 AU, that is empirical proof.
You found the concrete foundation.
Right. But if they scan that exact spot and find absolutely nothing structurally significant, the hypothesis takes a massive hit.
And that falsifiability is the gold standard of the scientific method. It elevates the silver ratio harmonic framework from just a neat numerical curiosity to a rigorous scientific hypothesis that can actually be tested with modern telescopes.
So let's zoom out a bit and look at the implications. If the math is this tight and the predictions are measurable, What does this actually say about the universe? Are we suggesting that gravity fundamentally operates on the silver ratio? Like, did Newton and Einstein somehow miss a square root of 2 in their equations of general relativity?
Yeah, we have to clearly define the boundaries of the research here. The author is explicitly clear that the SRHF is a phenomenological model.
Meaning it describes the phenomenon, the what, without necessarily explaining the underlying physical mechanism, the how or the why.
Correct. The paper does not attempt to explain the chaotic physics of planetary migration. It doesn't explain the grand tack hypothesis, where Jupiter migrated inward and then back outward, clearing the asteroid belt. It simply states, here is the final arrangement of the planets, and that final arrangement perfectly matches this geometry. To help conceptualize this, the author introduces the quantum celestial analogy, comparing the solar system to the Bohr atomic model.
Ah, early 20th century physics. Niels Bohr figuring out the atom.
Exactly. Niels Bohr discovered that electrons orbiting a nucleus don't just fly anywhere. They sit in discrete, quantized energy levels. He had the math to predict where those electron orbits would be, but he didn't have the full underlying theory of quantum mechanics to explain the physical forces dictating why they had to be there.
So he had the sheet music, but he didn't understand how the piano was built.
That is exactly the case here. This model identifies the discrete, quantized orbits of planets without proposing a new fundamental physical force. It is not claiming that gravity is a quantum effect, nor is it rewriting general relativity. It is merely observing a quantized macro-level outcome.
But could the silver ratio just be the mathematical signature of a system surviving chaos? Like, think about billions of years of planets tugging on each other, throwing debris into deep space, migrating closer to the sun. If a system doesn't settle into a stable resonance, it tears itself apart.
Right.
So is it possible that the only way a multi-planet system survives that violent history is if it eventually locks into a mathematical harmony?
That is actually the most conservative and scientifically sound interpretation offered in the text. The silver ratio isn't some magical tractor beam pulling planets into position. It is an effective organizing principle superposed on chaos.
Okay, that makes sense.
When you have massive bodies orbiting a star, gravitational resonances naturally form. We see this with Jupiter's moons. Actually, Io, Europa, and Ganymede are locked in a 1 to 2 to 4 orbital resonance. Their gravity literally forces them into a mathematical rhythm.
So silver ratio is kind of the ultimate resonance of our specific solar system.
Exactly. It acts as a hypothesis-generating tool. It provides future astrophysicists with a pristine target. Now, the burden of proof shifts to the dynamicists. They have to run the supercomputer simulations to figure out why the physics of orbital accretion and planetary migration ultimately distills down to a stable square root of 2 geometry.
It gives them the answer key to the final exam, and now they have to go back and show their work.
And the work to uncover that physical mechanism will likely redefine how we understand planetary formation.
Taking a step back, the journey from chaos to order here is just profound. I mean, we started with the assumption of a violently random early solar system, but now you know that beneath that chaotic history of crashing space rocks, our planetary neighborhood can be described by an incredibly precise silver ratio ladder,
Maintaining an average error of just 0.72%.
which is still blowing my mind. And there might be a ghost harmonic node, a missing fret on the cosmic guitar, waiting to be discovered at exactly 2.14 AU.
And the implications extend far beyond our own sun, too. The author emphasizes that as telescopes like James Webb discover more well-characterized exoplanet systems, we can apply this exact same framework to them.
Oh, wow.
We can map alien solar systems to see if they also follow a silver ratio ladder. If they do, we will have discovered a universal architectural rule of astrophysics. If they don't, well, it implies our solar system is a bizarre, highly unique numerical anomaly.
So the next time you see a headline about a newly discovered exoplanet system, pay close attention to how the planets are spaced.
Definitely.
But before we wrap up this deep dive, there is one final, almost haunting thought from the paper's limitations section that you should really mull over.
Yeah, it touches on the concept of deep time.
Yes. The author acknowledges that this entire model is built using fixed, time-averaged, semi-major axes based on the J2000 epoch.
Which is the exact state of the solar system in the year 2000.
Right. But planetary orbits are not entirely static. They evolve over giga-year timescales. The gravitational tug-of-war is incredibly slow, taking billions of years to physically shift a planet's path.
The architecture is alive. It is imperceptibly shifting over eons.
So if this harmonic structure is an effective organizing principle superposed on chaos, could it be that our solar system is currently just tuning itself to this silver ratio chord. We are seeing a snapshot in time. If you came back 3 billion years from now, would the planets have shifted deeper into this exact harmony, or might the entire solar system have evolved to play an entirely different mathematical chord?
A fascinating question.
Next time you look up at the night sky, don't just see a random scattering of rocks. Try to see the geometry. Try to hear the music.